Okay, we're looking at this and we're trying to figure out what's going to be less than 3060. Well, you need to realize that when you take your mean in this case minus your standard deviation, you get that number that we're looking for, 3060. So 3060 is approximately right in here. So we want to make sure that we are looking at what's to the left of that. Okay, just a second, I messed up. Sorry about that. When we're looking at 3060, that's about here. We're looking for what's to the left, and that's over here in this area. However, it's one standard deviation away. If you go one standard deviation away on each side of your mean, that is this area in here, and that's 68% of the data. Now, we know everything underneath the blue curve adds up to 100. Well, if we take everything underneath the blue curve, which is 100, take away that centerpiece, which we know is one standard deviation, that leaves us with 32%. That 32% covers both of these tails. We're only looking for the one tail. Well, if we know what both of them add up to, and they're both the same, we would then know that this tail over here to the left is 16%. The tail over here to the right is also 16%. We're only looking for what's on the left less than, so that means our answer is B. Keep in mind, whenever you're asked to use the 68, 95, 99.7 rule, the number that we're looking at right here is always going to be a whole number standard deviation above or below your mean. It's either going to be one standard deviation away, two standard deviations away, or three standard deviations away. In this case, our 2,635 is two standard deviations away. So if we take our 3,485 and subtract 2 of our standard deviations, we get our 2,635. Well, if you are within 2 standard deviations of the mean, you know that that's 95% of your data. So that's all in here, 2 standard deviations away from your mean on either side. Now, as we look over here, we are looking for greater than this. So that means we are looking for this whole area right here. Well, we know that 95 is within 2 standard deviations on each side. So if you consider, we got to look at this tail here, we got to look at this tail here. We know everything adds up to 100%. So when you take your 100% minus that 95% in the center, that leaves us with 5%. We need to know what each black tail is. Well, they both add up to 5%, so that means each black tail is 2.5%. However, when we are looking for what's greater than this mark right here, greater than this, that means we're looking for everything to the right of that, and that's that orange 95, plus at the far end over here, that 2.5. So that gives us then 97.5, or answer A. So as we are looking at this one here, what is false? Well, what is false is C. Your standard deviation does not have units, or is measured in the same units. Your z-scores don't have units. Okay. So as we look down at the next one here, we need to go to our table. For you guys, it would be your table in the back of your book. I don't have that, so I need to bring mine up here. And we are looking at between a 0, which is here, and a 1.5. So this is really a 1.50. So we need to go to a 1.5 on the left side, and then we need to go to the O0 because the second number right here has to be that one. We go down this column right here, we come across this row right here, and we get this. So we are looking for what is percent is in between. So we got to go ahead and take this number in the middle of the chart minus this number in the middle of the chart. So as we take a look at that, that's that 0.9332, and we need to subtract that 0.500. So that leaves us with a 0.4332. Changing that to a percent, we have to move our decimal point over 2 spots. We get 43.32%. Meaning answer B. Okay, so on this one here, it's not a full number standard deviation above or below the mean, so we can't use the 68, 95, 99.7 rule. And even if it was, it doesn't say to do that, so we don't want to go ahead and use that rule. It's great at approximating those, but it's not asking us to approximate it here with that rule. So if it does not say to use that rule, do not use that rule. In each case, we need to go ahead and figure out a z-score. So I need to figure out a z-score for my 3600. So I need to remember my z-score formula. Remember, it's my data value minus your mean over your standard deviation. So I'm going to go z, in this case, is equal to my 3600 minus my mean over my standard deviation. And I'm going to go ahead and work that out. So I get a 115 over 425 and divide that, and I get a 0.27. And whenever you're looking at your z-score, you want to always go to the nearest 2 decimal points. Well, then we want to go ahead and do the same thing for our 2800. So our data value minus our mean over our standard deviation. Go ahead and subtract the top and divide. Now we need to go ahead and go to our table in the back of our book. And by the way, when you get to a quiz, you'll be given a copy of this table, so don't be concerned about that. And I need to find the z-score for each one of those. So when you look at your table, you actually have the positive side here, or you have the negative side here. Now, for the blue one, we're going to have to use the positive half. So when you're looking in the back of your book, that's going to be the table on the right side of your page. And now I need to go to, in this case, just a second here, I need to go to a 0.2 on the left-hand column. 0.2 on the left-hand column is here. Then the next number over after my 0.2 is that 0.07. So I got to go to that 0.07 here. So I need to go across this row and down this column, and then I end up getting this number right here. So I'm going to have to write that down. Then I also need to do that for the green one, but that's a negative, so I need to go ahead and pull up my negative one, which for you guys would be the one that's on the left-hand page. So now I need to find what I have there. Now notice it's a negative 1.6. So I need to go to a negative 1.6 on the left-hand column, and then I need to go ahead and look at that number afterwards, and that's a 1. That's a 0, 1. So I need to go to that one there, come across this here, come down here, and I find that number. That's what I need to write down. What I need to do is I need to go ahead and subtract these two numbers. subtract those two numbers, and then that will tell me the portion of what's in between here. So I go ahead and subtract those. So then I get 55.27%, or that would be answer C. Now, what does this actually look like on our standard normal curve? Well, when I look at the blue, I got to look at where my mean is right here, and I got to go just almost a little bit above my mean, which would be about here. Then I got to look at my other one here. I got to go almost 1.5 to the left here. And I'm really concerned about what's this shaded area in between. And that's what I figured out when I looked at this.